All right, so the best way I think I could explain what we're about to do today, which is the derivatives and the integrals of sine, cosine, the natural log of x, and e to the x, is by looking at the graphs. And so to start, I want to look at the graph of sine curve, which looks like this. And so if I was to do the graph of the derivative, remember how we do this, okay? The first thing you do is you find your max or your min, and that would be your points where the slope is 0. So we highlight those by putting a point right there at 0, right underneath where that maximum and minimum point is. Then we notice the slope. And the slope, as you notice here, and I'll use a different color here so I don't mess myself up, but this section here, you'll notice, is positive. It's going up until we get to that spot. That's where the maximum is. And so that part of the f prime graph then would be up. And then from this maximum spot to the minimum, you'll notice that, oh, it's below. And then it increases again and comes up. Well, what does that graph look like? My hope is that you're quickly saying, wait a minute, that derivative of sine, so if f of x is sine x, then f prime of x looks a lot like cosine x. And I would, yeah, exactly. That is the deal. Now, in a similar fashion, what if I look at the cosine curve? Okay, and in the same way that you were just looking for the sine, again, you have a maximum, a minimum, and a maximum, and so those would be your zeros, right? And so we would spot those, and now between the first maximum and the minimum, you'll notice it's decreasing, and then between the other two, it's increasing. Well, it looks very close to the sine curve. If f of x is cosine x, f prime of x, it is a form of sine, but it is negative. And so that is the derivative of cosine. So I'm going to flip to this, and I'll come back here in a second. But the derivative of sine is cosine. And the derivative of cosine is negative sine. Okay, so now let's think through this. If I'm doing the integral, remember that's the opposite. So if I'm doing the integral, and I'll actually start with cosine. See, if we're going to do the integral, or I'm going backwards, then the integral of cosine is sine. And the integral of sine, be very careful, is negative cosine of x. Yes, there should be the plus c because these are indefinite right there, so just pay attention to that. I would definitely write these down. These are frequently confused between the sine and the cosine, which one gets the negative and which one doesn't. I'll tell you, it's one of those things that I even refresh my memory frequently about because you don't want to get them mixed up. It'll totally mess up your answers, and yes, both options will be a choice. Okay, now, on the flip side of that, let's look at another graph. Let's look at the e to the x graph. If you remember, this is e to the x, okay? It crosses at 1. So if I was to do the derivative graph of this, we would first highlight the minimum or maximum, which there isn't any. But then I would notice the pattern of the slope. Well, this is very close to 0, okay? So the slope would also be very close to 0. And then it slowly increases, and you'll notice it's constantly above. Well, what do you notice about the graph of the derivative? It is true that f of x is e to the x, and believe it or not, the derivative is also e to the x. And so the derivative of e to the x, guess what, is e to the x. And the integral of e to the x, oh, ta-da, is e to the x. Isn't that beautiful? Last but not least is the natural log graph. And so just to cap this off, we have the natural log graph. It looks something like this. Okay, so let's talk about its derivative graph. You'll notice that the slope here, although is constantly positive, it starts extremely steep here, so it would be very high, and then it starts to go to 0, so it would almost look like this. And that would be the derivative graph. Well, maybe it's not quite as obvious to you what that graph is. The original graph, of course, is the natural log, but the derivative is 1 over x. And so the derivative of natural log is 1 over x, and the integral of 1 over x is the natural log of x plus c. So you'll see those two being applied in your homework assignment tonight, and my hope is that you can just quickly see those rules. We'll learn how to apply them tomorrow in class with different values. So hopefully that's good enough. And you'll be able to answer those two questions that you see on your homework today.